Daddy Kumar.
मेरा वक्त बर्बाद here.
उसके बदले क्या फोन काट दीजिए ये मेरी खूरा देखे किसी की गलती नहीं फिर हम क्या करें वो जीना सिखाती
If I'm on what's of your mind, that is not a move. That's a good mind.
I just wanna move with you गिराना चाहते जो मुझे छू भी ना सकते डूबी डबे जरा सोचे आप बेशरम ठहरे unapologetically क्यों हमें शर्मिंदा करे
अगर दिखता नहीं तू मेरे पीछे तय में दुश्मन तुम लोग सबसे तेज नहीं वो मेरे मगज के बोझड़े बच्चे वो जीने का शिकना बाकी मुझे क्यों उड़ के बीच से चले जाए तू
मगज को क्या फाड़ी जाए
नोनी की योनी तुम मेरी नहीं योनी तुम मेरी नहीं बनी और बनने से अपने आप को खोनी तो खोड़ा अपने यार के लिए इतना करे तू मैं भी देखूं मैं बिगड़ लेता गाँव से मेरे दोस्तों इतना जो बच गया दोस्त नहीं रहा जाए बोले माये मारनो की लगी हम भी फॉर्म भर के जाके होके बढ़ती दूसरी जिंदगी चेती मेरे को ये पसंद नहीं पर मैं नशे में उके नहीं ऐसा तो पूछ मत पूछ मार दी सबकी बूझ मैं बना कुछ नहीं ऐसे कुछ पर हुआ नहीं खुश
I'm sorry.
Welcome to Engineering Funda family. This video is a part of Microprocessor 8085 video lecture series, and in this video I'll be explaining you the basic differences in between microprocessor and microcontroller. Here I'll be explaining you what is microprocessor and what is microcontroller and how both are different with. Welcome to Engineering Funda family. This video is a part of Microprocessor 8085 video lecture series, and in this video I'll be explaining you the basic differences in between microprocessor and microcontroller. Here I'll be explaining you what is microprocessor and what is microcontroller and how both are different with respect to each other. There are some similarities even, but here our major focus is there based on what are the differences. So when we talk about microprocessor, my dear students, it is a single chip which is used to execute programs. Here our agenda is to execute instructions by using microprocessor. Microprocessor does not have input-output peripherals. Microprocessor does not have memory within it. But when we talk about microcontroller, so microcontroller do have some memory in its one package. So as if you observe one chip of microcontroller, so it is having memory inside in which you can store the program. So this is what the basic difference. You'll be observing with microcontroller, there will be timers inside that single chip. While with microprocessor, you don't have timer inside. You will be having input-output peripherals connection with that microcontroller, but that will not be available with microprocessor. So this is the major difference. Let me explain you all the basic differences one by one so it will be more clear. So my dear students, when we talk about microprocessor and microcontroller, then you see microprocessor contains CPU. And you'll be observing memory, IO interfacing and timers. Those are separately provided with microprocessor. But when we talk about microcontroller, so in that CPU, memory, IO, timers, all those things, that is available in a single chip. Now, if you see how designer is selecting microprocessor, so once designer is identifying particular microprocessor, designer can decide how much memory can be interfaced as well as how much input-output handling capacity is used over here with this given computer system. But when we talk about microcontroller, in that you'll be having fixed size of ROM, RAM and IO as it is there with single chip. But with microprocessor, we can decide how much size of ROM and RAM that would be interfaced, right? So this is major advantage of microprocessor in which we can have a facility of upgradation. That is not possible with microcontroller. Now, when we talk about multitasking, then you'll be observing microprocessor is way better in multitasking compared to microcontroller. Now, you'll be observing this microprocessor that is used for general purpose. Like you can do many things. Like by my computer, what I do is I perform video editing, I perform making of PPT, I perform making of programs, designing of antennas, many things that I perform, and I can say that is general purpose. But with microcontroller, I need to be very specific. I cannot do many things as it is possible with microprocessor. It is what? Therefore, specific purpose. When we talk about architecture, then with microprocessor, mostly one human architecture is been seen. But there are some microprocessor that is available with Harvard architecture, but mostly you'll be observing one human is there. And I'm talking about this in 2022. So it is possible that after 2022, you may be observing Harvard may take over one human. That is possible, right? So architecture will be one human mostly with microprocessor and Harvard mostly with microcontroller. Now, when we talk about speed and cost, then microprocessor is having very high speed of operation and cost is also very high. And microcontroller cost is relatively low as well as it is having lower speed of operation. It requires more hardware to be interfaced with microprocessor as it is having only one chip and it does not include memory, IO and timers. So all those things that we need to interface it with microprocessor. So it requires more hardware to be interfaced with microprocessor. While with microcontroller, you'll be observing it is having CPU, memory, IO, timer on a single chip. So you will be having less requirement of interfacing of hardware. So by boards even you can observe by AVR microcontroller on a single board, there are many things, but you will be observing board of microprocessor that will be very huge. I'm showing you that by graphics over here, you can see board of microprocessor and board of microcontroller. So that will give you more clear idea like why it is having more interfacing, right? So microprocessor mostly does not support single bit addressability and microcontroller that supports single bit addressability, that will be observing why. The reason is when you perform some projects by microcontroller, in that you may need to operate with single LED or you may need to operate with single switch. So all those things that we do it with microcontroller. That's why there is a need of single bit addressability. But when we talk about microprocessor, so that is not designed to perform simple tasks like operation of one switch or operation of single LED, something like that. Here we are interfacing complex devices, right? Here we will be talking about graphics and all those things. That's why mostly you'll be observing microprocessor does not provide single bit addressability. Now, let me give you some examples like 8085, 8086, Core i3, Core i5, Core i7, AMD processors are available in the market. While when we talk about microcontroller, so 8051, AVR, PIC and ARM microcontrollers are available. In ARM, microprocessors are also available, but ARM microcontroller are also very famous microcontrollers. That's why I have listed it over here. So my dear students, here what you can understand is by having microprocessor, you can perform huge tasks. You can perform tasks based on graphics, based on high definition games, based on designing of many programs. You can design antenna, you can design 3D models in microprocessors. But when we talk about microcontroller, at that time we are performing lower category of tasks. Like you can have serial communication with 2 kbps speed, 3 kbps speed, this kind of operations that we can have. Like we can have projects based on pressing of key, identification of LEDs blinking or not, or you can have some basic projects based on generation of sine wave, square wave, all those things that we do it by having microcontroller. But higher computational tasks that we usually perform with microprocessor. Why? The reason is it is having higher capabilities. And here one more thing that you should know, that is microprocessor does not have memory inside, as well as it does not have timers and all those things. All those things that we interface externally with microprocessor. While in case of microcontroller, there will be timers, IO ports as Welcome to Engineering Funda family. This video is a part of Microprocessor 8085 video lecture series, and in this video, I'll be
Yeah.
how to count memory. Welcome to Engineering Funda family. This video is a part of Microprocessor. Welcome to Engineering Funda family. This video is a part of Microprocessor 8085 video lecture series, and in this video, I'll be going to explain you how to count memory. My dear students, after watching this video, you will be able to understand how many address lines and data lines are required for any given memory. It is not only the case which is there with 8085 microprocessor, but after watching this video, you will be able to understand what will be number of address lines and data lines for any given memory, right? So you'll be able to calculate generalizedly like for any processor or controller how to identify number of address lines and data lines. But before you go for how to count memory, there are some basics that is highly required that I would like to discuss in front of you. So let us see all those basics one by one. So first is what is byte. So my dear students, byte is 8 bits of binary number, and in terms of hexadecimal number, you'll be having 2 digits. So in binary, 8 bits are referred as byte, and in hex number, you'll have 2 digits. And when we talk about word, so in word, there are 16 bits in binary, and in terms of hex number, there are 4 digits. Now you might be thinking like, why I am talking about binary as well as hex? The reason is when we write memory data, we will be writing that in terms of hex number. We don't write that in terms of decimal system which we study in our school life. There are some reasons even, like you might be thinking, why don't we prefer decimal number system over hex? Why we prefer hex number system over decimal number system? There might be some questions, right? So I'll give you all those answers. Why do we prefer this hex number system over decimal number system? So for that, you need to understand first what is decimal number system. In decimal number system, we have 0 to 9, means total 10 digits are there. To represent 10 digits, there are 4 bits, right? And see, those 4 bits, that will be there from 0 to 9. And in terms of binary, it will be there from 0000 to 1001. So there are 4 bits which is possible with decimal number system, and you will be observing with 4 bits there are total 16 possibilities. But out of 16, how many we are utilizing it over here? Only 10 we are utilizing it over here. And when we talk about hexadecimal number system, so in that 0 to f digits are there, total 16 digits are there, and by 4 bits we represent that in terms of digit. So 0 is represented by 0000 and f is represented by 1111. So in binary, total 16 possibilities that we utilize. So one thing that should be crystal clear to you, that in decimal number system we don't use 6 binary codes. Those are from 10 to 15. While in hexadecimal we use all possible binary code which are there in 4 bits representation, right? So in binary number system, 10102, 1111 codes, those are not utilized over here. And in case of hexadecimal number system, 1010 is represented by A, then 1011 is represented by B, likewise 1111 is represented by F. So all the possible codes which are there in binary that we utilize over here in hex number system. Now one more thing that is very essential that you should know, my dear students, in decimal number system, when we operate with computer, it is very essential that you will have to convert that in binary. See, decimal number system is not utilized directly in computer system. In computer system, heart will be arithmetic and logic unit. So ALU cannot operate with decimal number system directly. It will be operating with binary data only. So as if you have decimal number system, then it is very essential given data in binary. The reason is hexadecimal system directly represents that data in terms of binary. See, in decimal number system, if you want to convert that into binary, then you have to perform divide by 2 operation, and after performing divide by 2 operation, many times you will be having binary data. But in hexadecimal system, all the digits are directly representing binary code. So here you don't need to have conversion. So that's why, my dear students, we don't use decimal system for representation of computer system. We use hexadecimal system to represent data in computer system. Now I'll explain you how we can identify total number of address lines. So if you have total 10 address lines, then how much possible combinations are there? 2 to the power 10. 2 to the power 10 means how much? 1024, and in short you can say 1 kilo. Now if you have 20 address lines, then you will be having 2 to the power 20 possible combination. So 2 to the power 20 means what? 2 to the power 10 into 2 to the power 10 means kilo into kilo, that will be mega. If you have 30 address lines, then it will be 2 to the power 20 into 2 to the power 10, that you can say, means you can say 1 mega into 1 kilo, that will be 1 giga. For 40 address lines, it will be 2 to the power 30 into 2 to the power 10, means it will be 1 giga into kilo, means it will be 1 tera. So my dear students, in short you can say for total 10 address lines, you need to have 1 kilo memory. For 20 address lines, you need to have 1 mega bits of memory. For 30 address lines, you need to have 1 giga memory, and for 40 address lines, you need to have 1 tera of memory. So here you can observe, if you have 1 address line, then there will be total 2 possible address. If you have 2 address line, then 2 to the power 2 means 4 possible address will be there. So these are the short names that you should understand. Why? The reason is, see, if you talk about 12 address lines, then how much memory will be there? So for 10 it will be 1k, and you can say that 2 to the power 10 into 2 to the power 2, so that will be 4 into 1k, means 4k memory is there for 12 address lines. If you have 24 address lines, then you can say 2 to the power 20, that is 1 mega, into 2 to the power 4 means 16, means you can say 16 megabytes of memory that can be there with 24 address lines. That is how directly we can identify the size of memory. So you should know, for 10 address line we need to have 1 kilo memory. For 20 address line we can have 1 megabyte of memory. For 30 we will be having 1 giga, and for 40 address lines we will be having 1 tera possible address locations. Now let me give you some examples so it will be more clear. So my dear students, here you see I have written 8k cross 8 means how much memory is there. So what is the meaning of 8k? You see this is indicating address and this is indicating data. So 8k means how many possible addresses are there? 8k means k means 1 kilo, 4 kilo, that will be 2 to the power 10, and 8 is having 2 to the power 3. So 3 plus 10 means 13 address lines will be there, and cross 8 indicates 8 data lines. So you can say here 8 over 3. So 8k means, so what is the meaning of 8k? You see this is indicating address and this is indicating data. So 8k means how many possible addresses are there? 8k means k means 1 kilo, 4 kilo, that will be 2 to the power 10, and 8 is having 2 to the power 3. So 3 plus 10 means 13 address lines will be there, and cross 8 indicates 8 data lines. So you can say here 8 kilobyte of memory that is there with this memory. Byte means 8 bits are there with individual address. Now here let us have second example in which 32k cross 8 is there. So 32 means what? 32 means 2 to the power 5, and k means what? 2 to the power 10. So 5 plus 10 means 15 address lines will be there, and cross 8 means there will be 8 data lines. Let us have one more example. So you see 32m means 32 mega is there. So here you see we'll be having 32, that is 2 to the power 5, and m means 2 to the power 20. So 5 plus 20, that will be 25 address lines, and cross 8 means there will be 8 data lines. Let us have one more example so that will get crystal clear. So my dear students, 4k cross 4 is written. Now here 4k means what? 4 into k. 4 means 2 to the power 2, and k means 2 to the power 10. So total 2 plus 10 means 12 address lines are there, and cross 4 means there are 4 data lines with individual address. So it is very essential that you should know with individual address how many data lines are there. So that is how we represent memory in general, and based on that you can identify how many address lines and data lines are there. So my dear students, I think now after watching this video you will be able to understand what is the size of memory which is there, and based on size of memory how to identify number of address lines and data lines. And if still any query is there, you just post that. Welcome to Engineering Funda family. This video is a part of Microprocessor 8085 video lecture series, and in this video I'll be going to explain you what is computer. I have seen students are having some issues in terms of understanding what is computer. Like when I ask this type of questions in Viva with my students, at that time I have seen some reply which was not expected initially from my side. So I thought I should give you a bit detailed understanding regarding what is computer. So after watching this video, you will be able to understand what is computer and how computer operates. So whenever we talk about computer, it is having a heart which is processor. You should understand this. Computer is having a heart, that is processor. Now what is processor? Processor is single chip, and in that single chip there are 3 major things which is there inside. One is arithmetic logic unit, second is register array, and third is control unit. Now that is single chip, remember this. It does not do anything more than execution of instructions. It is single chip and it performs what? It performs execution of instructions. It does not do anything more than execution of instructions. But to execute instructions, there are three things which is required. One is ALU, that is to calculate what is happening. Second is register array, that is to program. So there must be some registers by which we can do programming. For that there is a requirement of registers. And third is control unit. Control unit performs controlling task, right? So let us see how computer is there in terms of block diagram, so it will be more clear to you. So my dear students, here you see microprocessor, that is also referred as CPU, that is having three major elements: ALU, register array, and control unit. And it performs what? It executes instructions. So to execute instructions, first it needs to fetch the instructions, after that it will decode the instruction, and then it will execute instructions. So microprocessor that performs execution of instructions, and for that it is having three major elements: ALU, register array, and control unit. Now you will be observing how microprocessor is taking input. So for that there will be input peripherals like keyboard, mouse, and switch that will interface with microprocessor. So you'll be observing, like in your computer you'll be having keyboard, right, as well as you'll be having mouse. So those keyboard and mouse, those are input peripherals that will interface it with microprocessor. And in your computer you'll be observing, you'll be having output, and that output will be there in terms of display. You may be interfacing printer or LED to observe what is my. Welcome to Engineering Funda family. This video is a part of Microprocessor 8085 video lecture series, and in this video I'll be going to explain you how we can load program in memory with 8085 microprocessor. So here, before you go for understanding of how to load program in memory, my dear students, there are a few basic things that you must know. Like, see, one thing that is very essential that you should know, that is microprocessor does not have its internal memory. Here you will be interfacing external memory with microprocessor. So in block diagram of microprocessor, I have already explained that with microprocessor chip we interface external memory. Those memories can be ROM or RAM. Those are primary memories, right? And here, before you load program, you'll have to interface that external memory with 8085. So that is what the basic thing that you should know. You can see here, if I say this is my microprocessor block, then here input, output, peripherals that I have interfaced it with microprocessor, as well as this is memory, that is what we are externally interfacing it with microprocessor, right? So once you interface this memory with microprocessor, you can be able to execute programs which are there in this memory. So now question is how we can load the programs in memory. So before I explain you how to load program in the memory, my dear students, you should know with microprocessor, we are having multiple ways to write the program. Right now, first I'll explain you in general way of writing the program. With microprocessor 8085, we have only assembly language. But when we talk about microprocessors and microcontrollers, then we can write program in higher level language also. So there are basically two ways by which we can write programs in general for any microprocessor and microcontroller. One is higher level language programming, and second is assembly language programming. In higher level language programming, there can be multiple language that you can prefer, like C, C++, that is widely used to program microcontrollers and microprocessor, and assembly language programming that is also used for different categories of microprocessors and microcontroller. So there are basically two ways of writing code. You can observe here, I have listed that program can be written in two ways, higher level language and assembly language. When we talk about higher level language, then that is there in terms of C or C++, and in assembly language programming, there will be language with different processors and controllers. So different processors and controllers are having different sets of instructions that we use it for programming. I'll give you some basic examples even, like you see, if you write program in C, then simply you can write A is equals to B plus C. So what will happen? It will directly add B and C and it will store that in A. So this is simply we can write that in C language. While as if you see assembly language, then you see there are instructions that you have to study. Like when you write move A comma B, what will happen? Content of B that will get copied into A, and then if you write add C, then what will happen? Content of A will get added with C and answer will get stored into A. After that, if I write move B comma A, then content of A that will go inside B. So this is how instructions are there. Right now I'm not going in detail of instructions. What I'm saying is this is how instructions are there, and these instructions are there in terms of assembly language programming that one can say. And this assembly language programming that differs with respect to different processors and controller. But what is my agenda? My agenda is to tell you that there are multiple ways by which we can write the program. This is higher level language and this is assembly language. Now my dear students, whenever you are writing codes in higher level language like in C and C++, you will have to make sure that your program should be there in terms of machine code, and for that you need to have compiler. So what we do is we compile the program which is there in C or C++. After compiling the program, you will be having machine code. And even if you write program in assembly language, at that time you should be using assembler. So once you assemble the program, you will be having machine code which is understandable by this microprocessor. So my dear students, microprocessor that does not understand C, C++ or assembly language, it understands only machine code, or you can say lower level language. And that is there in extension of obj or .hex or .bin. So this files that we generated by using compiler. Now my dear students, I have seen there are many questions that is coming in interview, and in interview I have seen interviewer is asking students that what is the job of compiler, and I have seen students who have been replying them like compiler identifies how many errors are there. My dear students, compiler job is not to identify errors. Compiler job is to convert given higher level language into machine code. Yes, it do show you how many errors are there, in which line errors are there, right? But it is not the job of identification of errors. Its job is to convert given higher level language code into machine code so that microprocessor can understand it and it can execute instructions step by step, right? So here compiler is doing what? It is converting higher level language into machine code. Remember this. What is the job of assembler? Assembler is converting assembly language into machine code. So if you write program in assembly language, you will have to make sure before you load it into memory, you will have to convert that into machine code. So that's why we need assembler. If you write program in C, C++ or in any other language, you'll have to make sure that your program should be there in terms of machine code. And that's why we use compiler and assemblers. Yes, obviously compiler will show you errors, but main task of compiler is to convert higher level language into lower level language. Now, my dear students, once you identify that machine code, you can load that machine code into memory. And once you load that machine code into memory, by giving command to microprocessor, we can execute the program. So in next video, my dear students, I'll explain you how microprocessor executes program. Here I have shown you how we can install the program. Now my dear students, here one more thing that is very essential that you should know. What is memory? See, memory is having address and data. So it is structured like there are addresses in sequence, and with each address there will be data. Right. Now it is not compulsory that there is always data. It may be empty. You may need to fill it. Whatever data that we store inside the memory, based on that, there will be data which is there on the address. Right. So whenever you write program, you convert that into machine code. Then you just load it into memory. 164 kilobyte of memory that I can interface it with 8085. Welcome to Engineering Funda family. This video is a part of 8085 microprocessor video lecture series, and in this video I'll be going to explain you how we execute programs with processor. We don't have internal storage video. Now in this video I'll be going to explain you how we execute that program step by step with microprocessor. So my dear students, here there are a few basic things that you should know. See, microprocessor is having programming model which is having some sets of registers. Whenever you want to execute any program, at that time first register, that is program counter, that is playing very essential role. Program counter is having address of next instruction to be executed. So whatever program that you have inside the memory, for that program first instruction address that should be loaded into program counter. Once program counter is having that address of instruction, we can start execution of program. Now execution of program is not happening like all the instructions are executed parallelly. With 8085 it will not happen like this. In 8085 there will be execution of instruction one by one, and once it completes execution of all the instructions, you can say we have executed the program. So you should know first how one instruction is getting executed. Now, my dear students, when we talk about execution of one instruction, then in general, you'll be observing that it is executed in 3 steps. One is fetching of instruction, second is decoding of instruction, and third is execution of instruction. So it is not like microprocessor is executing instruction immediately like this. What it does is it executes first step, that is fetching. So what happens in fetching is it will be identifying the operation. So in fetching, what it does is it will identifying that what is opcode by which what has to be done in decode. In next step, there will be decode operation. In that, it will identify that which kind of operation that has to be done over here. And in third step, there will be it will identify by which what has to be done in. So in fetching, what it does is it will identifying that what is opcode by which what has to be done in decode. In next step, there will be decode operation. In that, it will identify that which kind of operation that has to be done over here. And in third step, there will be execution. So you'll be observing that all the instructions executed at 3 steps. Let us try to understand that how it is happening. So my dear students, as I have told you, in memory, we can store the program, and with first instruction, program counter will indicate address of that memory. Now, once you start to execute first instruction, what will happen? It will fetch it first, right? So see, basic execution of instruction with any microprocessor or controller, that is happening at 3 stages. First stage, that is fetch. So here processor load instruction from the memory. How it load instruction from the memory? Program counter will indicate the address, and at that address, whatever data that will be there, that will be opcode of that instruction. So it will load that opcode via data line, and it will get inside the microprocessor. So that is referred as fetching. So my dear students, you should know in memory here we will be having addresses, and here we will be having data. At address, there will be some data. In that data, there can be instruction or there can be data, right? So here we are talking about execution of instruction. So obviously at that address, we will be having instructions data. So program counter will indicate the instruction to be executed, and once you start execution, it will be taking that opcode. Opcode means that data which is there at first instruction, right? And once it fetch that opcode inside this microprocessor via data line, now microprocessor will start to understand what has to be done. So initial step, and once it fetch that opcode, it will be taking that opcode. Opcode means that data which is there at first instruction, right? And once it fetch that opcode inside this microprocessor via data line, now microprocessor will start to understand what has to be done. So initial step is what? It will have to take that first data which is there with that first address. That is referred as fetching. Once it takes that data which is opcode of that instruction, it has to understand what has to be done. So next step, that is to decode. So in decode operation, here processor will identify what operation has to be done. Like if you have written instruction which is based on move operation, then in decode we got to know like now we need to perform move operation over here. So what operation that we need to perform, that will get identified in decode operation, right? And third step, that will be execution. So once we decode what operation has to be performed over here, microprocessor does what? It will execute that operation via arithmetic and logic unit. So these 3 steps that will get performed to execute one instruction only. Once we complete this one instruction, what will happen? Program counter will move to next instruction, and next instruction that is ready to get fetched, and it will perform this task repeatedly till entire program gets completed. So that is how you will be performing execution of programs. So here I have discussed about one instruction only for as instruction cycle, and when you execute multiple instructions, that makes a program. And with that external memory, all we do is here instruction should get executed now. Fetch first opcode of that stored memory. Once it fetch that opcode, microprocessor will take that data and it will try to identify which operation should get completed over here. That is decode operation. Once it identifies which operation should be completed over here, it will execute that. That will be the third stage. So one is fetch, second is decode, and third is execute. That is how 3 stages are getting completed, and it will execute one instruction. Here it is very essential that you should know that microprocessor does not have its internal storage. Here we externally connect memory with microprocessor. In that memory, we store programs. So once you load program in the memory, we can execute that program. How we execute the program? So memory that is there with that program. Here program is loaded in the addresses of memory, and whatever address that is there with that program, that address will be given to program counter. So first instruction address that will be given to program counter. Program counter will fetch that code of first instruction once command is given to microprocessor. Once we give command, it will fetch that opcode. After fetching that opcode, what processor does? Processor tries to understand what is the meaning of that opcode. There are multiple instructions, so there are multiple meanings possible. So once it identifies that opcode is there for particular operation, it may be add operation, it may be subtract operation, it may be exchange operation, it may be move operation. There are many operations which are possible, right? That we will discuss it in other videos. So once it identifies that operation, that will be decode operation. And once it decodes which operation should be performed over here, it will execute that operation. So that is how 3 stages are there. And this is only a case of one instruction. So in sequence, one by one, it will execute instructions. Once it executes first instruction, you will be observing program counter automatically goes on the address of next instruction. Welcome to Engineering Funda family. This video is a part of Microprocessor 8085 video lecture series. And in this video, I'll be going to explain you what is machine language, what is higher level language, what is assembly language, as well as there are a few basic terminologies step by step. So here, when we talk about higher level language, then programmer prefers higher level language in terms of C, C++, generally when we work with microprocessor and microcontroller. But when we talk about assembly language, so that is what a language which is there with processor or controller, and that is based on instructions. So with all the processors and all the controllers, there is instruction set which is there with different processor and controller, and based on that instruction set, you can program microprocessor or microcontroller that will be there based on assembly language. So let us try to understand all those things by practical example so that will get more clear. So my dear students, when we talk about higher level language, then that is there in terms of C or C++ for most of the microprocessor and microcontroller. In industries even people are using C and CPP for programming of microprocessor and microcontroller. And when we talk about assembly language, so in assembly language, programming is done with the use of mnemonics of processor or controller, and mnemonics of processor or controller identifies instructions. So I'll explain you what is the meaning of mnemonics. My dear students, mnemonics means instructions code, right? So the way we write instructions, that is referred as mnemonics. For example, for 8085 microprocessor, when we write add B, so add B is referred as mnemonics for operation of addition of accumulator and B. When you write mnemonics move B, C, it indicates you will be moving data of C into B, and this is what mnemonics of movement of data from C to B. So mnemonics explains you the code word of instructions. For different microprocessor and microcontroller, different mnemonics are there, right? Let me explain you all those things by practical example so that will be more clear. So let us say we are talking about higher level language. So in C, CPP, we can do this operation in assembly language, A, B, that is written. After that again I have written move B, A. What it means? A will get transferred into B. So that is how we are writing instructions by mnemonics, and this is what assembly language that you can say. And this assembly language mnemonics are different for different microprocessor and microcontroller. Here we are talking about 8085 microprocessor. So with that, these are the mnemonics which are available. Now my job is to explain you what is machine language. So you cannot have directly machine language. Here there is a need of compiler and assembler. My dear students, here when we talk about higher level language, so higher level language that can be converted into machine language by using compiler. So main job of compiler is to convert higher level language into machine code or machine language. And compiler will also show you errors when you write syntax error, right? So compiler job that is to convert language into machine language. So my dear students, assembler job is similar to compiler. Only thing is when you write code in assembly language, at a time assembler will convert this assembly language into machine language, and assembler even can show you error as if there is syntax error or some logical error. But you should know in interview there are questions that is coming many times, like can you explain me what is compiler? So its job is to convert higher level language into machine language, and assembler's job is to convert assembly language into machine language. Now my dear students, what is machine language? So dear students, machine language is lower level language that is there in terms of binary. See, microprocessor cannot understand this higher programs in terms of binary code, and that binary code is referred as machine language, right? The reason is we cannot even remember how 1010 that we need to write with respect to different instructions, right? So my dear students, here what we do, we cannot programs in terms of binary code, and that binary code is referred as machine language, right? The reason is we cannot even remember how you want to operate with 5 to 7 different microprocessor or microcontroller, then is it possible that you can remember instructions for that many processor and controller? Simply no, right? So what you do is you learn only few languages like C, CPP. So by using C, CPP, we can be able to program in a single way, and by using that single way, by using compiler, we convert that C language code into machine code. Machine code is always there in terms of binary. The reason is microprocessor and microcontroller does not understand any other thing than zeros and ones. Here, why don't we write code in terms of machine code? See, you don't write codes in terms of machine code. The reason is it is very complicated to remember that many numbers. How can you remember 0101 sequence for different instructions? You cannot remember sequence of zeros and ones, right? You can understand some mnemonics of assembly language, or you can understand programming language like C or CPP. If you give efforts in that direction, then you can be able to program many things, right? So if you have knowledge about C or CPP, definitely you are eligible to program any microprocessor or microcontroller. In that situation, only thing is you will have to understand what is programming model of given microprocessor or microcontroller. Programming model means how many resistors are there which is available for programming purpose. Once you understand that programming model, you can directly start making programs by using C and CPP. So when you go in industries of embedded system, at a time it is very essential that you should know C and C++ language. By having that language, you can be able to program many other embedded devices, right? Only thing is you should know how to compile the code, and whatever errors are there in compiler, you just resolve it and you can load it into processor or controller, right? The reason is machine language that could be easily understood by processor or controller. So that is how things are there with microprocessor as well as microcontroller. This video is in general video, right, where there are a few basic things that you must know. The reason is this world is getting digitized, and in future many other things that will come in front of you which is there based on programming. And welcome to Engineering Friend of Family. This video is a part of Microprocessor 8085 video lecture series, and in this video I'll be going to explain you architecture of 8085. You can see in my background I have shown architecture, and at first look you might be thinking this is quite complicated, but I'm giving you guarantee after watching this video you will be able to easily remember this architecture, as well as you will know that how this architecture is functioning and how signals are flowing inside and what will be the direction of signals within that architecture. So all those things that you will get to know after watching this video. So let me show you this architecture step by step so it will be more clear. So my dear students, if you observe this architecture, so in this architecture you see here we are having resistors, and this resistors is referred as programming model of 8085. Here we are having arithmetic and logic unit that is performing arithmetic operation. Here we are having interrupt control that is to perform interrupt and service routine. Here we are having serial IO control where we want to have serial communication, so for that serial in data and serial out data is there. And here instruction register and instruction decoder segment is there, right? So that is how complete architecture is there. But let us try to understand this architecture step by step so it will be more clear and you can easily remember how this architecture is getting formed. So my dear students, first of all you should know how many resistors are there with 8085. So this section that explains you programming model of 8085, and in this programming model we are having 7 general purpose resistors. You see this one resistor that is accumulator, and then B, C, D, E, H, L. So these resistors are general purpose resistor. Why it is referred as general purpose resistor? The reason is programmer can do programming by using these 7 resistors. general purpose resistor. Why it is referred as general purpose resistor? The reason is programmer can do programming by using these 7 resistors are general purpose resistor. One resistor, that is accumulator, and then B, C, D, E, H, L. So these resistors are general purpose resistor. Why it is referred as general purpose resistor? The reason is programmer can do programming by using these 7 resistors. And here I have written 8. What it means? These resistors are having size of 8 bits. And these are general purpose resistors. After that, you see here we have stack pointer. This stack pointer is indicating top of stack and its size is of 16 bits. After that, you see here we have program counter. So that is also of 16 bits. It is indicating where our next instruction is there in the memory, right? So next instruction location will be addressed by this program counter. And after that, incrementer and decrementer is there. This incrementer operation that is happening with program counter. Once one instruction is getting executed, program counter will get incremented by 1 automatically. For that, there is incrementer. For stack pointer, there can be incrementer and decrementer operation. For stack operation, I will be making separate video in which I'll explain you how push and pop is happening and how stack is operated with 8085. Here, just understand this. Stack pointer is used with stack operation in which push and pop that we do it with 8085. And with push, we will be having decremental of this address latch. So it will decrement stack pointer. And with pop, we will be incrementing stack pointer. After execution of each instruction, program counter will get incremented by this incremental address latch. Now here, you might be thinking, what is happening with this W and Z? These are temporary resistor and these are not available with programmers. And these resistors are used by 8085. So internally, there are some functions which is happening with W and Z. For some instructions, I'll be separately explaining you how W and Z is utilized by 8085, but this is not available for programmer. Now, my dear students, here temporary resistor is there as well as flag resistor is there. So that we will discuss once we have ALU operation. And here we have instruction resistor and instruction decoder. That even I'll explain you when I explain how this 8085 is functioning. In this video only, we will be learning that. Let us see first how internal structure is there. So you see here, this programming model that is connected with address and data buffer. There are total 16 address lines A0 to A15 and total 8 data lines D0 to D7. But you observe here AD0 to AD7, that is how address data lines are time multiplexed. So on same line there will be address as well as data, and that we need to separate by using address latch enable. That we will discuss it in some other video. But remember one thing, with 8085 we have total 16 address lines and 8 data lines. Now this address lines will be having address that will be indicated by program counter, right? And whatever address is there, that address will be there with memory, and from memory we will be executing instruction. For that, I'll give you one complete example so that will be more clear. First, you just see how architecture is there. So my dear students, once you understand these are the address lines and data line, you need to understand internal data bus. So whatever data that we fetch it from here, that data bus is connected internally. So you see I have shown it over here. And after that, here you see timing and control unit that is being connected over here. And once you understand timing and control unit, you will be able to understand how ALU is connected over here. I'll be discussing everything in detail, so don't worry about it. Now, if you observe this timing and control unit and arithmetic and logic unit, so that is connected over here, as you can see it in this figure. And here we have interrupt control segment in which we have INTR, INTA and RST 5.5, 6.5, 7.5 and trap interrupt signal. And over here you see we have serial IO control in which serial input data and serial output data is there. And this timing and control unit that provides timing and control to enter microprocessor 8085. You see it is providing timing and control to enter microprocessor. Right. Now, let us try to understand how this entire architecture is functioning by one practical example. So my dear students, first of all you should understand microprocessor 8085. Does not have its own memory. So we externally interface 8085 with external memory. Now that external memory will be having address and data, right? This external memory will be having address and data. Now here program counter will be indicating address of next instruction. So once we give signal to 8085 that execute program, then what will happen? It will be having address of first instruction in program counter. So what it does is it will be giving signal to memory, and at that particular address, whatever data is there, that it will took it from AD0 to AD line. So first it will give address to memory. Once it give address to memory, it will read that data which was there on that memory. And those data, those are D0 to D7 that will get fetched inside. If you see my previous video, in that I have already told you, microprocessor 8085 executes instruction in 3 steps. First is fetch, second is decode, and third is execute. So first step is what? First step is fetch. Fetch means what? First of all, program counter will indicate address. From that address of memory, it will fetch the data. Once that data is going inside, that data that will come inside means it is getting fetched. Once that data is getting fetched, that data will go in instruction register. That data will go in instruction register. Once that data goes in instruction register, it needs to identify that what operation should be getting done. And based on that, this data that will go in instruction decoder. So now second operation will get started, that is decode. Decode means what? Microprocessor does not have idea what has to be done. Decode will tell you that what has to be done. So in second stage, there is a decode operation. And in that decode operation, this block will identify what operation has to be performed. Once it identifies what operation has to be performed, that will be given to timing and control. So timing and control will be having idea what operation has to be performed. There can be multiple operation, there can be move operation, there can be add operation, there can be any operation as per instruction, right? So once it is having that idea that what operation should be performed, timing and control, that will be giving timing and control to each of the blocks which are there inside, right? Now let us take example like here program counter is indicating one address, and in that address there is operation which is add b, right? So for add b, whatever opcode is there, that is coming inside over here on data bus. So that opcode will come over here first at instruction register. That instruction register will take that opcode and that it gives to instruction decoder. So that will be second stage in which instruction decoder will identify what operation should be done. Now here add operation should be done. So for add operation, it needs to give timing and control to this block, and once execution is getting initiated, timing and control will tell ALU that you will have to perform add operation. So with ALU, here there are two registers you see. Here these two registers are operand of this ALU that you can say, and with a architecture of 8085 you can say this accumulator is fixed operand. So one operand is fixed, second operand that could be B, C, D, E, H, L, it could be any other register, but one operand is fixed. Now here I want to execute add B. So add B means what? One operand is accumulator, second operand is B, both will get added, and once both are getting added, output will come over here, that will get stored in accumulator again, and with respect to operation, flags will get changed. Flags will show you status of the 8085. So flag register is 8-bit register in that SZACPCY, S stands for sign, Z stands for 0, AC stands for auxiliary carry, P stands for parity, and CY stands for carry. So that is how 5 bits of flags are there inside of this 8 bits of flag register, which will indicate status of the program. And you will be observing after every instruction, this flag register is getting modified by ALU, and it is bidirectional you see. The reason is ALU needs flag register as well as whatever operands are over here. So along with operands and flag register, it will perform complete execution and it will give output. This interrupt control, that is having interrupt service routine, and there are many things. For that I have made a separate video for this, and the serial communication, that even I'll be explaining you separately. So right now you just consider that in this way. Interrupt control is having INTR, interrupt request, INT A bar, interrupt acknowledgement line, and then there are 4 hardware interrupt, RST 5.5, 6.5, 7.5, and trap. Trap is non-maskable interrupt, and here SID and SOD, those are 2 lines which is there for serial communication. So serial IO control is there. So my dear students, whenever you want to execute any program, it will happen in step-by-step execution. So it will execute one instruction. In single instruction execution, there are 3 stages. At first stage, it will fetch instruction. For fetch instruction, over this 80 to 87 line, it will be taking data, and that data will go inside. It will go inside this instruction register. In second stage, there will be decode operation. In decode operation, this instruction decoder will identify what operation should be done. In execution, it will be giving this to timing and control, which will provide what operation to be performed by this ALU based on operand, which is accumulator and temporary register and flag register. ALU will perform operation, and after operation, there will be modified data which will be there in accumulator and on this data bus. And my dear students, once it executes one instruction, program counter that is already ready for second instruction to be executed. So one by one, this program counter will increment by 1, and it will be fetching next instruction, and in sequence all the instructions are getting executed. But here frequency of this 8085, that is ranging from 2 megahertz to 6 megahertz. So you don't realize this is happening in sequence, but my dear students, all those things that is happening in sequence. So I think now it is clear to you how entire architecture is there with 8085, and this is a backbone of this subject. I hope it is clear to you. I think to sequence all the instructions are getting executed, but here frequency of this 8085, that is ranging from 2 megahertz to 6 megahertz. So you don't realize this is happening in sequence, but my dear students, all those things that is happening in sequence. So I think now it is clear to you how entire architecture is there with 8085, and this is a backbone of this subject. I hope. Welcome to Engineering Funda family. This video is a part of Microprocessor 8085 video lecture series, and in this video I'll be going to explain you pin diagram of 8085 microprocessor. Before you watch this video, I request you to see my previous video based on block diagram of 8085 so that you can understand there with 8085, and I'll explain you each and every pin in great detail in this video. So let us try to understand first how power supply and clock frequency pins are there with 8085. So in power supply, there are 2 pins. One is VCC and second is ground. So VCC is connected with 5 voltage supply with respect to ground, that is reference. And when we talk about clock frequency, so that is provided at X1 and X2 terminal. X1 and X2 terminal is connected with crystal clock over here. So crystal oscillator will generate clock signal over here, and inside microprocessor 8085, that clock frequency will get divided by 2. So here, if you want to operate with 8085 at 3 megahertz of frequency, then you should have clock over here with 6 megahertz with this crystal clock oscillator. Now, why do we need to divide frequency by 2 with microprocessor 8085? The reason is with microprocessor 8085, we need to have 50% of duty cycle. With X1 and X2, it is possible that you have duty cycle that is greater than 50% or lower than 50%. If it is having greater than 50% duty cycle, then my dear students, you will be having logic high with higher time period compared to logic low. And with lower than 50% duty cycle, you will be having logic high that is having lower time period compared to logic low. But with microprocessor, we need to have 50% duty cycle which is having equal time with logic high and equal time with logic low. The reason is, if you have 50% duty cycle, then there will be proper timing and synchronization which is happening inside. So here with microprocessor, what we do is we use one flip-flop. By using that, what we do is we provide logic high for one clock and logic low for second clock. You observe this is one clock which is there with this X1 and X2. During that, we have logic high. With second clock, you see we have logic low. So if you observe this much time period, in that X1 and X2 is having 2 clocks. But with microprocessor, we have only 1 clock. What it means, we are dividing frequency by 2 to operate with this microprocessor at 50% duty cycle. So remember this, if you have crystal frequency which is 6 megahertz, then you will be having 3 megahertz of operating frequency. That is very essential that you should know. Now, my dear students, I'll explain you this terminal, that is clock out terminal. So clock out terminal, that is used to provide clock to external peripheral which we interface it with 8085. So this terminal is used to give clock to peripherals. Now, my dear students, I'll be going to explain you address and data buses. Now, address bus give clock to peripherals. Now, my dear students, students, I'll be going to explain you address and data buses. Now address bus, that is of 16 lines over here with microprocessor 8085. So microprocessor provides 16 bits of address via these lines that you can see it over here, that is bisected into two parts, higher byte and lower byte. Higher byte is having A15 to A8 and lower byte that is time multiplexed, that is AD7 to AD0. Now AD7 to AD0, that is having time multiplexed address data line. And with respect to time, we can latch address and data, that I'll explain you with respect to address latch enable terminal. Now when we talk about data lines, then in data line we have total 8 lines, which is AD0 to AD7. On that we will be having address as well as data line. Now because of we are multiplexing address and data on same line, you can reduce the size of microprocessor and you can save the number of lines. Now you'll be observing in earlier part of instruction cycles there will be address lines, and later part you'll be having data. How it will be identified? That will get identified based on ALE terminal, that is address latch enable. Address latch enable will provide positive going pulse, and during that positive going pulse we can latch addresses. So this AD0 to AD7, that will be having addresses when there will be positive going pulse over ALE. When ALE is equals to 0, this AD0 to AD7 that will holds data. So that is how address and data that we can utilize over these lines. Now let us try to understand control signals which is there with 8085. So 8085 is having this many control signals: ALE, read bar, write bar, IO read bar, S0 and S1. ALE, that is address latch enable, which we have already discussed. Now let us talk about read bar. So read bar, that is a terminal which is connected over here, you can see, and that is active low terminal, means it is bar that is indicated over here. What it means, whenever this is getting 0, microprocessor can perform read operation. So over the data line, microprocessor can read data whenever this is getting active low. When we talk about write bar, that is also active low terminal, where as if it is going low, in that case microprocessor can perform write operation, and that write operation that we can perform over AD0 to AD7 lines. So that read and write operation over here that we can have for IO or memory devices, that you should know. Now how IO or memory devices are there, let us try to understand that. So IO or memory that we identify based on this terminal, that is IO memory bar. As if this terminal is logic 1, then microprocessor will perform IO operation, and as if this is logic 0, in that case microprocessor will perform memory operations. Now my dear students, two very essential lines, those are S0, S1, that I'll be going to explain you, will perform memory operations. Now my dear students, two very essential lines, those are S0, S1, that in that case microprocessor will perform memory operations. Now my dear students, two very essential lines, those are S0, S1, that I'll be going to explain you, that is over here, you can see, and that is showing you status of the signals. Now here, to remember this status, I'll tell you one simple trick, but before that you see this table over here, and in this status of the signal that we can understand with respect to S1 and S0, where you see whenever you have S1, S0, 1, 0, at that time input operation will happen, remember this. And whenever you have S1, S0, 0, 1, at that time output operation that will happen, remember this. So as if S1, S0 that is having input operation. Input means what? There will be input with respect to microprocessor. So input with respect to microprocessor means read operation will happen. So S1, S0 that is 1, 0 means read operation means input operation will happen. And if IO memory bar that is 0, then memory read will happen. If S1, S0 that is 0, 1, then output operation will happen, means microprocessor will write. If IO memory bar is 0, then memory write, that will happen, that you can say. Now you see S1, S0 that is 1, 0 again, but with IO memory bar is 1 means IO operation will happen, and 1, 0 of S1, S0 means there will be read operation. And again, when IO write is happening with IO memory bar is equals to 1, at the time S1, S0 that should be 0, 1. So you should know for read S1, S0 that should be 1, 0, and for write S1, S0 should be 0, 1. For memory read, memory write, IO memory bar should be 0, and for IO read, IO write, IO memory bar that should be 1. Now there are two essential other things that is there with S1, S0, that is a case of 1, 1 you see. Whenever S1, S0 that is 1, 1, at that time we need to see whether it is memory operation or IO operation. If it is memory operation, right, means this IO is equals to IO memory bar is equals to 0. In that case there will be opcode fetch. So opcode fetch means what? It will be giving you execution of instruction from the memory via program counter, right? So program counter will indicate instructions in the memory, and we can fetch that instruction by having IO memory bar is equals to 0 and S1, S0 is equals to 1, 1. But when you have IO memory bar is equals to 1 with S1, S0 is equals to 1, 1, at a time we will be providing interrupt acknowledgement. The reason is with IO devices we will be providing interrupt service, right? So interrupt acknowledgement that we give by having IO memory bar that is equals to 1 as well as S1, S0 is equals to 1, 1. Whenever you have IO memory bar that is there in high impedance mode, right, at that time you'll have to see what is happening with S1 and S0. So if it is 0, 0, in that case you'll be having halt, but if it is don't care, in that case there can be two possibility. One is hold machine cycle or reset machine cycle, which is happening with microprocessor 8085. And during these three operations you'll be observing read write will go in high impedance state, and interrupt acknowledgement bar that will be equals to 1, right? So that is how S0 and S1 that is showing you status of 8085. So detailed status that you can understand by S1 and S0, you should understand this. Now my dear students, I'll be going to explain you reset and ready terminals. So first I'll explain you reset in bar. So that is active low signal as it is reset in bar. Whenever reset in bar that goes low, at the time 8085 that will start to get reset. Whenever it is getting reset, program counter will goes to 0000 location, and all the buses that will go in tri-state mode. How to provide reset to 8085? So here by animation I'm showing you. You see we are having 8085 with which we are having reset in terminal, and that is what input you at the time 80 set in bar. and S0. So if it is 0 0, in that case you'll be having halt. But if it is don't care, in that case there can be two possibility. One is hold machine cycle or reset machine cycle, which is happening with microprocessor 8085. And during these three operations you'll be observing read write will go in high impedance state and interrupt acknowledgement bar that will be equals to 1. Right. So that is how S0 and S1 that is showing you status of 8085. So detailed status that you can understand by S1 and S0, you should understand this. Now my dear students, I'll be going to explain you reset and ready terminals. So first I'll explain you reset in bar. So that is active low signal as it is reset in bar. Whenever reset in bar that goes low at a time 8085, that will start to get reset. Whenever it is getting reset, program counter will goes to 0000 location and all the buses that will go in tri-state mode. How to provide reset to 8085? So here by animation I'm showing you. You see we are having 8085 with which we are having reset in terminal, and that is what input to the microprocessor that you can see. So when you give ground connection by switch, as I'm showing it to you over here, microprocessor will get reset over here. And here pull-up resistor is connected. What it means, if you don't press that switch, then microprocessor will not get reset. But once you press that switch, microprocessor will get active low signal on reset in, and microprocessor will get start to reset by this terminal. Right. Now next is reset out. So obviously reset out, that is to reset peripherals which is interfaced with microprocessor. So whenever microprocessor is getting reset, in acknowledgement, microprocessor will provide reset to other peripherals which are connected by this terminal. Will not get reset. But once you press that switch, with which we are having reset, it is reset in bar. Whenever reset in bar that goes low at a time 8085, that will start to get reset. Whenever it is getting reset, program counter will goes to 0000 location and all the buses that will go in tri-state mode. How to provide reset to 8085? So here by animation I'm showing you. You see we are having 8085 with which we are having reset in terminal, and that is what input to the microprocessor that you can see. So when you give ground connection by switch, as I'm showing it to you over here, microprocessor will get reset over here. And here pull-up resistor is connected. What it means, if you don't press that switch, then microprocessor will not get reset. But once you press that switch, microprocessor will get active low signal on reset in, and microprocessor will get start to reset by this terminal. Right. Now next is reset out. So obviously reset out, that is to reset peripherals which is interfaced with microprocessor. So whenever microprocessor is getting reset, in acknowledgement, microprocessor will provide reset to other peripherals which are connected with microprocessor. Right. Like you might have seen, whenever you shut down your computer, at that time you will be observing that printer is connected, along with that computer is also getting reset. Right. Whenever you restart that, that is what happening with peripherals which is connected along with that microprocessor. Right. So only microprocessor is not getting reset, peripherals are also getting reset, and that is happening by this reset out terminal. So when we have reset of microprocessor, this terminal that will go active high to reset other peripherals which are connected with 8085. Now ready terminal, that is quite interesting terminal that you should know. See, this signal is used to delay microprocessor read and write cycles until a slow responding peripheral is ready to send or receive the data. So when you connect microprocessor with other devices, and if those devices are slow, so in that case this ready terminal will be input to microprocessor. Means those slow devices will tell microprocessor that you need to wait for some time period, and when the signal goes high, then only microprocessor can work with those slow devices. So whenever you have different speeds of peripherals, at that time slower devices will have to tell microprocessor that right now you just wait for some time period. Here there will be active low signal which indicates microprocessor will have to wait for some time period. That will be based on integer number of cycles. Once that is getting high, once that cycle is getting complete, you will be having microprocessor that is ready to operate with all those devices. Right. So this signal that is to provide halt operation that you can say with this microprocessor, so that we can have proper data exchange with slower devices. Now my dear students, I'll be going to explain you serial data communication. So there are two terminals, SOD and SID, serial out data and serial input data. Serial input data, that is to take serial in with this microprocessor 8085, and serial out data, that is to give serial data to peripheral devices. Right. And here serial communication, that is having advantage, that is a cost. If you have lower speed of data transfer application, in that case we can have serial communication. If you want high speed data communication, in that case you should have parallel communication. Right. So this feature is also available in which we can have lower speed of communication, like we see it in telephone exchange. Now my dear students, I'll be going to explain you interrupt of 8085. So you can observe these many lines. These are associated with. Now my dear students, I'll be going to. This feature is also available in which we can have lower speed of communication, like we see it in telephone exchange. Now, right. So this feature is also available in which we can have lower speed of communication, like these are associated with 8085 interrupt, in which you see this INTR, that is interrupt request line. Whenever this interrupt is getting executed, this microprocessor will go in interrupt service routine. So for that I'll be making separate videos. Here just understand, whenever interrupt is given, microprocessor will go in interrupt service routine, and INTR, that is general purpose interrupt, and that is having lowest priority. And as you see, this RST 5.5, RST 6.5 and RST 7.5, that is having higher priority than INTR. And this interrupt acknowledgement line, that is active low line, and that is to acknowledge requested interrupt. So once you get interrupt over here at 8085, 8085 will provide interrupt acknowledgement. Right. And during that time period there will be interrupt service routine that will happen with 8085. So we will see that in great detail. Here right now you just understand this. These are interrupt lines. So RST 5.5, 6.5 and 7.5, that is also interrupt. Those are vectored interrupt. Vectored interrupt means when these interrupts are getting executed, at a time microprocessor will transfer its command to well specified memory locations. Right. So these are the interrupt, those are vector interrupt, these are hardware interrupt even. And priority wise, see, INTR is having lowest priority. After that you have higher priority with this interrupts, right? And highest priority, that is there with trap. that is non-maskable interrupt that is having highest priority. Even I'll be explaining you all this interrupt in great detail with separate video. The reason is interrupt service routine and all those things that I cannot cover with pin diagram, right? So right now you just understand this. There are 5 hardware interrupt and 1 interrupt acknowledgement line. So interrupt will be input to microprocessor, that is to interrupt this microprocessor functions, right? Now my dear students, I'll be going to explain you DMA signals processor, that is to interrupt this microprocessor functions, right? Now my dear students, I'll be going to explain you DMA signals. Those are HLDA and HOLD. This is hold and this is hold acknowledgement. And these two terminals that we use it for faster data exchange in between memory and input output peripherals. If you observe, microprocessor does not have its own memory, so we will be interfacing input output as well as memory with microprocessor. But just think about as if memory and input output wants to exchange the data in between each other, then what will happen with 8085? So obviously, what will happen? Microprocessor will take data from memory and then it will give it to input output devices. So what will happen here? Microprocessor will execute cycles 2 times. One is to take data from memory and second is to give it to input output devices. But what if we remove all those things, like directly if we transfer data in between input output and memory? So for that we need to have DMA, direct memory access. So that we are able to see it in great detail in other videos, but just think about this. This DMA will provide hold signal to microprocessor, and that signal is being provided by DMA to make sure that DMA takes control over this address and data lines. Why? The reason is input output and memory does not have capability to provide control signals. Control signals can be provided by microprocessor only, right? You see here, these are the control signals that is provided by microprocessor. So here, to take control, DMA will give hold request to 8085. Once this 8085 accepts that hold request, that control will get transferred to DMA, and DMA will exchange data directly in between input output and memory, so that exchange will be very fast. So you see, hold is the signal that will be given by DMA to request the control of address and data, and hold acknowledgement, that is acknowledgement by 8085, right, to that hold which is given by DMA. So that is how these two terminals are there. Still we will be observing these two terminals in great detail when I explain you interfacing of DMA with 8085. So microprocessor 8085 is having 40 terminals, and I think after watching this video you can be able to say how all those pins are functioning. Later when I interface many other peripherals at that time, it will get crystal clear to you how we operate with 8085 along with all those pins. Still, if any confusion is there, just post that in comment box. Definitely I'll try to make sure that all those confusions are getting cleared in future videos. Thank you so much for watching this video.
Yeah. Hoje não sei quem
मुझे भूल जाने मत देना तुम मुझे भूलना नहीं मुझे डूब जाने मत देना मुझे दूर जाने मत देना तुम मुझे खो जाने मत देना तुम मुझे खोना
उनका साथ मत दे, मेरा साथ दे। उनका साथ मत दे, मेरा साथ दे।
क्या बात है? क्या बात है? वाह!
वो बोलेंगे मेरा साथ मत दे, उनका साथ दे, हाथ दे। ये समय सर हमारे भीतर अंदर निरंतर चलते रहे। आगे पीछे मत दे, कैसा चल लेते। चल, बाबर जी, चल। क्या कर ले, हिम्मत रख, बहुत बदलेगी। मैं जो लिखूं पर थोड़ा तरल बहुत अच्छी बदलेगी। अब अच्छी वाली अच्छा 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 हमने आपको दोहराते आया है और इंडिया सबने आपको दोहराएगा एक दोहराएगा यस क्यों फिर दोबारा आएगा तो सही करने का मौका प्लीज नहीं आएगा कभी रीजन दिख जाएगा पर सुकून तब भी नहीं मिल पाएगा ये गरीब का साथ तुम लोग कुछ की बराबर में जानता अगली बारी तो बोल रहे हैं नहीं रहे eternal quest to stand the test of time deflated ये नहीं eternal rain ये सब good forever sign सर्वज्ञानी है ये संप्रदाय मिलके समझाए जो वक्त और तू समझे वो जब उनमें अंतर हो तब तो वो शब्द और उनके संचों के संबंध को अस्तित्व मिलता तब यानी कि ये पेशकश नहीं है पेट दस्ती बातें लेट बस्ती ये अटकने में थोड़ी देर लगती पेशेंस वाले पेचेक मिले नेक्स्ट सेंचुरी बीती सदी पे सदी यानी कभी खेद लगती है पिछले को मुक्ति दे अगले को जेन सकती चली एक से देर तक केस क्लोज ब्यों केस बख्शी तेरी सोच भले जितनी भी तेज भक्ति जितना ही दूर का सोचे ये आंखें कितना ही दूर देख सकती मेरे पीछे एक नेक शक्ति मेरे पीछे अनेक शक्ति नहीं है एक सस्ती ये जमाना भरी पड़ी भेड़ बकरी में ना एक बक्सी मेरा चलते बच्चाने को बेग रसी देखते डांस की तुम्हारी बस देखो भी ये सूचना नहीं है साइकिल है जैसे जुर्म की भी क्या एक साइकिल है ना चाहते देखी नजदीक से क्या मेन थिंग आज भी साइड पर है जब तक सबके पेल का पैसा नहीं आके बैठ जाता कहीं यहाँ पे मेरे हाथ पर है समाज में तेरी जा रहे क्या कोई ना सके सकती है बहुत नहीं मान लो प्रचार परिवार की भी एक साइकिल है भाईचारे की एक्सपायरी हो तो काई करे पॉलिसी बताइए जीवन अब कैसे कटे लेजिस्लेटर अभी भी हमारे साथ गलत ना होने दे ये राज में एक सौदा है दुख किसी का बढ़ता बनना नहीं तुम्हारा छोटा है पहली बात से कंपेयर करना ही छोटा है दुख छोड़ना बनना नहीं डर नहीं होता और कुछ लोग उस दुख में डूब के बस खो जाए लाख लाख आवाज़ में घूम रहे विचार सोचे कि ये पेन जब पेपर लगा इस बार तो पक्का मैं ही बेहजार में ही बाहर जार में कोई सुनना चाहिए बस एक आवाज जो मेरे को दुनिया तक पहुंचा दे बार बार बोल के एक आवाज सुनना दे बहुत से गवा पर कोई नहीं गुन्ना ये जज देख रहा हो सब देख रहा है लाख लाख आवाज़ में घूम रहे विचार लगे में साथे दिलासा दिलाते दिल पे छुपे जाते और मगज किसका दे अंदर सब जानते पर बात किसका दिखाते हिस्सा टू हिस्सा बे सीख किसका चल गया सीख ली कल बाकी अपना अपना देख लेंगे सब मैं व्यस्त जब तक नहीं नर्स फिर मिलेंगे किधर इधर पर अगली सप्ताह का
मुझे भूल जाने मत देना तुम मुझे भूल
हाँ तुमने एक बात क्यों कि अगर नहीं हुआ तो
Come नहीं ये तू और वो मैं
बराबर की नहीं सो कंप्लीट करके एक शेयर करके ही रखे अमदार सीडी दंजी कुमार शाशा और शाउट आउट टू संगीत तुम्हारे देसी रखो योगदान नो चांस ये दिन का मिन का नो चांस ये लूप पे रख के जो का इनको मोक्ष प्राप्त मैं लूप पे फंस गया जैसे पुनर्जन्म से लीक रहा हूँ one true love with the one true rhythm you can call this dungeism I never needed a reason पर जब भी पैसा मिसिंग तो तभी पेसिमिज्म तो जब भी लातिन लिखित में थोड़ा जाके लिसन पर अगर पास दिक्कत पड़ती तो थोड़ा ध्यान से लिसन ना बेबी लिसन में रिवाइंड दिस दोबारा लिसन तू मेरे को भूतकाल में सुना तो तेरे आज में डिफरेंस और बाल तो चेक करवा के जा टूकड़ा ने परवाने काम इतने साल से एक भी नहीं सुना किसी का तो आज भी काहेगा मैं गाहेगा तेरे को समझ आए कि नहीं आएगा मेरा धक्के खाने का शौक नहीं है आवाज़ तो बोल दे शाउट आउट टू संगीत तुम्हारे देसी रखो योगदान है योगदान इसको रोक डाल नहीं तो शो स्टॉप ये लूप पे रख के ही जो गए इनको मोक्ष प्राप्त मैं लूप पे फंस गया जैसे पुनर्जन्म से लीक रहा हूँ देख रहा हूँ अभी जा देख रहा हूँ देख रहा हूँ देख रहा हूँ देख रहा हूँ थोड़ा ज्यादा देख रहा हूँ
ये रैपर बच्चे मेरे दिख रहा हूँ ये पैदा हुए जब मैं गैंग को डिक्टेड डाउन लिरिक्स लाओ जाओ तेरा क्या हुआ शीट पे टू पाउ डेडलाइन पर लेवल रकम पूछो तेरा भाव देख क्या है
करके सीखा
तूने गलती कर दी भाई उसमें से भी सीखा तेरे गाने तांत्रिक विद्या खड़ी मौसों के लिए नहीं से जब तू भी तो तरीका तो चलता रहा मैं तेरे लिए इस तो लिखता एक का देखना एक खराब बात थी मैंने बहुत कहा देखे तब से उस बात में नहीं तो बोल दे हम मास्टर जी मैंने सीखा जीवन कैसे जी और उसने ये पारो प्रो शांति री मैंने कोई भविष्यवाणी के सारे को आके थमाते सही बात है हाथ में सारे बात तो वही क्या वही है ये नसी नसी की बातें का क्या बात है इस पे गौर ना दे तो पाप पर बात सच आ जाओ तारी साड़ी साथी उतारे वाली
बेंचो तुम्हारा देसी रैप को योगदान हुड मेरा गाम आधी रात को चक्का जाम मेरे पीछे मौत पूछे अगर करना मोक्ष प्राप्त मैं लूप में फंस गया जैसे पुनर्जन्म से लिख रहा देख रहा हूँ 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 देख रहा हूँ
थोड़ा चाह दिख रहा
देख रहा हूँ देख रहा हूँ
તો હારી વાત ના કહેવાય
ના તો નથી જ ને ભાઈ
બે પણ તો આ નાગાઈ કઈ રીતના બંધાય
નાગાયા બંધન ના ગુજરાતીઝ આર સચ શિટ્સ
તો હેટ
ની બાબતમાં તો શિટ્સ જ
તને તો હેટ હે યાર ગુજરાતીને પ્રત્યે
અલગ લેવલનો ઇન્ડિયન્સ માટે જ મને તો હેટ હે પણ અમેરિકન મસ્ત માણસો હું જો પેલા સ્કેમ કરતો ને એમાં એક ઘોડી તો સેટ થઈ ગઈ હતી ભાઈ
શું નામ હે
નામ તો એપ્રિલ નામ હતું એપ્રિલ પહેલાની વાત એ તો સેટ થઈ ગઈ હતી તો પછી મેં સ્કેમ પછી મને તો મારે નહીં કરવો એનો સ્કેમ પછી મેં કીધું કે આમ સ્કેમ કહી દીધું મેં અને મેં કીધું આઈ એમ નોટ લીવ ઇન યુનાઇટેડ સ્ટેટ્સ મને કે સો વોટ મને કે I really like you can we meet like you just give me the address I'll come over there we can spend some time together and it's not possible so she said like why number 858 હતો કેલિફોર્નિયા LA નો નંબર મને I know you are from LA
સુધીની
તો મેં કીધું I'm from India અહેમદાબાદ તો પછી શું કે ખબર no you're lying to me you don't want to meet me that's why you're telling me like this
એ યાર
મેં કીધું No, of course not. So, wait. I'll make you a video call and then you will see. Then video call in Gujarat.
सीढ़ी ऊके तो पहुंचे भी नहीं भाई अभी तो पहुंचे भी नहीं भाई बाबा के नहीं
कदों की ये झूठ
से परख देखो वो करते रहने की बात मुर्शिद नाल निकलता उसे जल्दी यार ये लेवल जाते हल्लो मिलके सिग्नेचर साइन कर डाले तो मेरा वाला सिग्नेचर भी के सेट में साइन बाजी चले इधर पार्टी चले संग साथ भी डरे मत बुलाने देना मेरे को इधर बाकी सारे And it's speaking for the generation. I got this groove under the nation. नहीं दरवटे डे पास होने में भाई खुद इस बारे साथ जिन्हें देख ले दाखले डचने तो ये what's the action man बस कह दो कि ये ऐसा नहीं ये और ऐसा है पर के नेट पे सब सच हो जाए तो है कि ये झूठ है कह दो कि ये झूठ है में होएगा लोचा मेरे साइड से एकदम क्लियर है चेंज बननी है नोट है मेरी एक इच्छा है बचपन में था 1 रुपया 4 बाय तो अभी कुछ भी नहीं करना एक चौथा है तो अबे जाना बेचो जाना बेचा तेरे को नहीं जाने ना तो मेरे को पूछी मत बा मैं ये लिख रहा था जब मैं लिखा बहुत कुछ आग में आंसू मेरा दिल भरा देख थोड़ा बात जुबा बोला बहुत दंजी काका तुम्हारा तो जानती लोगी बोला जानती तो सोना क्या बकायदा बाकी एक छोटा लगा मैं अखे गैंग को चलते गान से पैगाम बगा शाउट आउट टू संगीत तुम्हारे देश को योगदान नो चांस ये दिन का मिनका नो चांस ये लूप पे रख के जो का इनको मोक्ष प्राप्त मैं लूप पे फंस गया जैसे पुनर्जन्म से लीक रहा हूँ 1 2 love with the 1 2 rhythm you can call this dungeism not never needed a reason पर जब भी पैसा मिसिंग तो तभी पैसे मिसन तो जब भी लाटिन लिखित में थोड़ा जाके लिसन पर अगर पास दिक्कत पड़ती तो थोड़ा ध्यान से लिसन ना बेबी लिसन में रिवाइंड दिस दोबारा लिसन तू मेरे को भूतकाल में सुना तो तेरे आज में डिफरेंस और बाल तो चेक करवा के जा टुकड़ा ने परवाने काम इतने साल से एक भी नहीं सुना किसी का तो आज भी काहेगा मैं गाहेगा तेरे को समझ आए कि नहीं आएगा मेरा धक्के खाने का शौक नहीं है बात तो बोल दे शाउट आउट तो संगीत तो तुम्हारे देसी रैप को योगदान है योगदान इसको रोक डाल नहीं तो शो स्टॉप ये लूप पे रख के ही जो गए इनको मोक्ष प्राप्त मैं लूप पे फंस गया जैसे पुनर्जन्म से लिख रहा हूँ देख रहा हूँ थोड़ा चा दिख रहा देख रहा हूँ
Just
Welcome to Engineering Funda family. This video is a part of Microprocessor 8085 video lecture series, and in this video I'll be going to explain you pin diagram of 8085 microprocessor. Before you watch this video, I request you
Take a seat.
Welcome to Engineering Funda family. This video is a part of Microprocessor 8085 video lecture series, and in this video I'll be going to explain you buses in 8085. Now before I explain you different categories of buses which is there with 8085, my dear students, you should know what is buses. See, buses means lines which are connected from 8085 to memory input and output devices. Here we are dealing with to transfer data, here we are dealing with to exchange data, as well as here we are dealing with to manipulate the data. So all those things that needs to exchange which are connected from 8085 to memory input and output devices. Here we are dealing with to transfer data, here we are dealing with to exchange data, as well as here we are dealing with to manipulate the data. So all those things that needs to exchange in between memory and processor, in between input devices and processor, in between output devices and processor. For that we need to interface connection. Those connections are electrical connections, and here there are many lines which are connected in between these devices with processor. Those lines are buses. Through these lines we will be sending electrical signal, and that electrical signal will be having data which is there in form of binary. So 1010 that we continuously send over the line, and whatever those data are there, that will be operated with that microprocessor, and by programming we can do many things, right? So here when we talk about buses, that is just electrical connection in between microprocessor and memory input and output devices. Here basically three categories of buses are there with microprocessor connection. First is address lines, second is data line, and third is control lines. So you can say in terms of buses, that is address bus, data bus, and control bus. How those buses are essential and how many buses are there, all those things that we will discuss step by step. So let us see that graphically as well as how many things are there inside. So my dear students, here we are having microprocessor 8085. With this microprocessor we interface memory. With 8085, memory will be primary memory only, so that can be ROM or RAM. After that we can interface input devices. In input devices you can interface keyboard or switch, as well as we can interface output devices like LCD and LED. You see I'm interfacing it with this all these devices. That address will be decided by 8085, and this address that will get indicated by program counter of this 8085, right? So address bus, that is unidirectional only. You see it is happening from the microprocessor and it is going inside the memory as well as input output devices. So microprocessor gives address to these peripherals, right? Now with this address buses you'll be observing there are a total 16 address bus, A0 to A15, which is there with 8085 microprocessor, and these buses are used to identify the address of given memory or input output peripherals. So address buses, that is there with the capacity of 16 buses, A0 to A15, that will get indicated by program counter, and that will identify what will be the address of that memory as well as input output. So total 16 address buses are there, and it is happening from microprocessor. It is unidirectional buses. Now second buses will be control bus. So control bus is also unidirectional. Here control bus is providing control to the memory input and output devices. Usually you will be observing there are total 4 category of control signals which is provided by microprocessor. Those control signals will be memory read, memory write, input output read, and input output write. And via this control signal, microprocessor controls operation with respect to memory input and output devices. Now third category of buses, that will be data bus. Now you will be observing data bus are bidirectional, right? It is bidirectional with memory. It is one directional with input and output, and you see by arrow it is shown over here. See, in memory there can be ROM or RAM. As if it is there with ROM, in that case microprocessor only reads data from the ROM. So if ROM is there, in that case only direction that will be there from memory to microprocessor, unidirection will be there. But if RAM is there, in that case microprocessor may give data to the RAM. So in that case there will be bidirectional arrow, that you must know. So for RAM you will be having bidirectional arrow. Why? The reason is you may do read or write operation. If read operation is there, then memory to microprocessor arrow will be there. If write operation is there, then microprocessor to memory arrow will be there. Here both are happening, so bidirectional arrow is shown. With input we take only input, so you see arrow is there from input to microprocessor. So here input is having inward direction with respect to microprocessor, that you can say, and on output microprocessor displays data. So you see from microprocessor towards output arrow is there. So in general you can say that this data bus are bidirectional, but you should know even with memory in case of RAM it will be bidirectional. After that you will have to understand what is that which microprocessor performs over here. Is it read operation? If it is read operation, then direction will be there towards microprocessor. Like you see input is given by these devices, so microprocessor will read that input, so direction is there from input to the microprocessor. In case of output, microprocessor will give data, so direction will be from microprocessor to output. So that is how memory input and output devices are connected via buses. So in data bus with microprocessor 8085 there are total 8 data lines, D0 to D7, and these are bidirectional lines. And here this direction will be based on read and write operation, which I have already explained. So my dear students, whenever we talk about buses, this direction will be total 8 data lines, D0 to D7, and these are bidirectional lines. And here this direction with buses of 8085 with peripherals. I hope you have understood this. Still, if any, welcome to Engineering Funda family. This video is a part of 8085 microprocessor video lecture series, and in this video I'll be going to explain you flag register of 8085. My dear students, I have already explained in architecture that flag register explains you status of program after every instruction. Flag register is directly connected with ALU of 8085, and after execution of every single instruction, status of flag register will change. Flag register of 8085, that is of 8 bits, but out of 8 bits there are 5 bits that is used by microprocessor and 3 bits are unused. So I'll explain you all those 5 bits of flag register of 8085 by one practical example, so that will get more clear. So let us see first of all how flag register is there with 8085. So if you observe there are total 8 bits which is there with 8085 flag register, but these 3 bits are not used. And how to remember this name of flag? So see, I used to remember it in this way: SZACPCY. SZACPCY. S stands for sign, Z stands for 0, AC stands for auxiliary carry, P stands for parity, and CY stands for carry. Now my dear students, before I explain you meaning of all these flags, let us see one example, and that example that I'll correlate it with this all the flags. So here I'm taking one example in which what I'll do is I'll be providing MVI A, CC hex, means content of A, that will be CC hex. Then MVI B, E6 hex means content of B, now that will be E6 hex. And after that I'll be adding B with A. Add B means what? B is getting added with A and answer will get stored in A. So that is how one example that I'm taking. Now you see A, that is CC after executing first instruction, B, that is E6 after executing second instruction, and when I execute add B, so you will be having modified A, that will be addition of A and B. Now here what I have done is I have represented same thing in binary. You see CC means 1 1 0 0 1 1 0 0 and E6 means E is 1 1 1 0 and 6 is 0 1 1 0. Now if I add both, you see 0 0 will be 0, 0 1 will be 1, 1 1 will be 0 carry 1 over here, 1 1 will be again 0 carry 1 over here, then 1 0 0, that addition will be 1, then 0 1 addition is 1, 1 1 addition is 0 carry 1 over here, then 1 1 1 is 1 with carry 1. So that is how addition is happening, and this data that is there in accumulator, that is 1 0 1 1 means B and 0 0 1 0 that is 2. So this is one example, right? Now let us try to understand this example by this flag register. So you see this first flag, that is carry flag. Now with this carry flag, if CY is equals to 1, what it indicates? It indicates carry is generated after execution of instruction. So you see when I execute this program, after add B, you can observe this carry is generated over here. What it means? After execution of add B, you will be having carry flag that will get set to 1 over here, right? So this flag will be equals to 1 after execution of this instruction. Now my dear students, I'll explain you parity flag. So what is parity flag? Parity flag explains result has even number of ones, means parity is equals to 1. If result is having odd number of ones, then parity is equals to 0. So you see after add B operation, A is having B2, means it is having total 4 ones, you can observe, means it is having total even numbers of ones. So here after execution of this program, after add B instruction execution, this parity P that will get set to 1 over here. Now my dear students, let us try to understand auxiliary carry. So my dear students, auxiliary carry means what? It is nibble to nibble carry. Nibble to nibble carry means what? After 4 bits, if carry is generated, that is referred as nibble to nibble carry. Means if carry is happening from D3 to D4, right? If carry is happening from D3 to D4, then that is referred as nibble to nibble carry, right? So that auxiliary carry that will get set 1 when carry is happening from D3 to D4 bit, that is also referred as nibble to nibble carry. If it is not happening, then auxiliary carry is equals to 0. So you see in this operation, this is one nibble, that you can say nibble means 4 bits. This auxiliary carry that will get set to 0. Means if Z is equals to 1, what it indicates? After execution result should be 0. Here you see result is not 0. Result is B2, right? As result is B2, you can say it is not 0. Result should be 0. Here indicates result is equals to 0. Means if Z is equals to 1, what it indicates? After execution result should be 0. Here you see result is not 0. Result is B2, right? As result is B2, you can say it is not 0. As it is not 0, after execution of this program, you will be having Z is equals to 0 over here with this flag register. Now let us try to understand what is this S flag, that is sign flag. So sign flag that indicates D7 bit of result. So here you see D7 bit that is having 1, means S is equals to 1 over here. So for signed number, you can say data is negative, right? For signed number, if S is equals to 1, it indicates data is negative. But for unsigned number, you don't need to worry about this sign flag, right? But sign flag that we need to focus about whenever we are talking about signed number. So my dear students,
So my dear
for
sir,
signed number, if S is equals to 1, it indicates data is negative. But for unsigned right now, thank you so much for watching this video. Welcome to Engineering Funda family. This video is a part of 8085 microprocessor video lecture series, and in this video, I'll be going to explain you programming model of 8085. Now, before I explain you programming model of 8085, let me tell you a few basic things. See, programming model explains you how many registers are available for a programmer for programming of 8085, right? Like in architecture, I have already discussed, we are having sets of registers, but all those registers which are in use of programmer, that is what we are able to see it in this video of programming model of 8085. So let us see how many registers are there in programming model of 8085. So you can observe here, accumulator, flag register, B, C, D, E, H, L, stack pointer and program counter. These are the registers that we have it for programming of 8085. So for programming of 8085, here address bus and data bus are there, and this address bus and data bus that is being connected with external memory. Stack pointer will indicate the address of instruction, and via data bus we will fetch those data, right? But here I'll not discuss all those things. Here I'll discuss how we utilize all these registers. So first essential register is accumulator. My dear students, accumulator is of 8 bits, and this is main register of 8085. As it is default operand of ALU. In architecture also I have told you all the operation of 8085 that will happen with respect to accumulator, as it is default operand of arithmetic and logic unit of 8085. So that is referred as A when you do programming, when you write instructions, and full name is accumulator, right? Now second register that is also very essential, that is showing status of program, that is flag register. I have already explained flag register with separate video. In that I have told there are 5 essential flags: S, Z, A, C, P, C, Y, sign, 0, auxiliary carry, parity and carry flag. And these flags are used to write many instructions, like as if you want to write jump if 0, right? Then you will have to make sure in previous instruction there should be 0 operation. In that case there will be jump operation to the location which we indicate. Likewise, jump if carry, jump if no carry. That is how many instructions are there. Those are conditional instructions by using which you can program many things, right? So flag register and accumulator, these two, those are operation essential flags as of discuss all those things. Here I'll discuss how we utilize all these registers. So first essential register is accumulator. My dear students, accumulator is of 8 bits and this is main register of 8085 as it is default operand of ALU. In architecture also I have told you all the operation of 8085 that will happen with respect to accumulator as it is default operand of arithmetic and logic unit of 8085. So that is referred as A when you do programming, when you write instructions, and full name is accumulator, right? Now second register that is also very essential, that is showing status of program, that is flag register. I have already explained flag register with separate video. In that I have told there are 5 essential flags S, Z, ACP, CY, sign, 0, auxiliary carry, parity and carry flag. And these flags are used to write many instructions, like as if you want to write jump if 0, right? Then you will have to make sure in previous instruction there should be 0 operation. In that case there will be jump operation to the location which we indicate. Likewise jump if carry, jump if no carry, that is how many instructions are there. Those are conditional instructions by using which you can program many things, right? So flag register and accumulator, these two are main essential registers. Flag register that we need to focus about. We are not directly writing data in flag, we are observing data of flag and based on that we write program. That's why I am suggesting you that you should focus about what is happening with flag register after execution of each instruction. Now you'll be observing here we are having other registers like B, C, D, E, H, L. So my dear students, I am writing that as per general purpose register, and general purpose register means what? That is available for programming. So accumulator A, then B, C, D, E, H, L, that is available for programming and that is having size of 8 bits. You can observe, right? So these are general purpose register A, then B, C, D, E, H, L. And these registers that we use it to make program. Whenever you write program at that time you will be using these registers only, right? That's why it is referred as general purpose registers. Sometimes in programming you may need to have 16 bits of operation. At that time we can use these registers in pair also, like you can use BC as a pair, you can use DE as a pair, you can use HL as a pair for programming. So these A, B, C, D, E, HL, that is general purpose register, and B, C, D, E and HL can be used in pair. Here you cannot use pair of B and E or H and E, that is how you cannot have pair. There is a pair with B, C, D, E and HL, remember this. Now my dear students, I'll explain you very essential register, that is program counter, that is of 16 bits and it is used to execute program in sequence where program counter points address from which the next byte is to be fetched. So here with 8085 we are interfacing memory, and in memory whatever address is indicated by program counter, at that address next instruction will get fetched. So after execution of every instruction, program counter will incremented by 1 automatically to point next instruction. Now let us see what is happening with stack pointer. So stack pointer is also of 16 bits and 8085 that is using stack pointer as a memory pointer, and it is pointing read and write memory, that is referred as stack. Here my dear students, stack is pointing address which is a top of stack. So whatever data that is there in stack pointer, that is holding address of top of stack. Stack is a memory, remember this, and that is read write memory. To use stack we need to use push and pop instructions, that even I'll be going to explain you in great detail with separate video. So you just don't worry about how stack is getting operated over here. You just think like stack pointer, that is a pointer which is used by 8085, memory pointer is there with SP, and it is used for read and write memory which is stack, and that will be pointing top of stack. So my dear students, when we talk about programming model, it should be very clear to you why do we need to have programming model. See, there are total 7 registers which is used for detail with separate video. So you just don't worry about how stack is getting operated over here. You just think like stack pointer, that is a pointer which is used by 8085, memory pointer is there with SP, and it is used for read and write memory which is stack, and that will be pointing top of stack. So my dear students, which is get automatically incremented by 1. For that you have to use stack pointer. And when we talk about flag register, so that is to understand how status is there.
Sweet therapy.
Welcome to Engineering Funda family. This video is a part of 8085 microprocessor video lecture series, and in this video I'll be going to explain you generation of control signals in 8085 microprocessors. If you have seen my previous video based on pin diagram of microprocessor, in that we have been having control signals like read bar, write bar and input output memory bar. But those three pins that cannot be directly given to input output devices as well as memory. The reason is when we talk about control signals, then there are four essential control signals that is there with microprocessor. Those are memory read, memory write, input output read and input output write. So by using three terminals, read bar, write bar and input output memory bar, we need to generate control signals. So how to generate those control signals, that I'll be going to explain you over here step by step. So you just see this video till last. Definitely you'll be able to understand this, and this concept that you can utilize while you interface processor 8085 is memory read and memory write, that is therefore memory operation. You should know the basics of these three terminals. First is input output memory bar terminal, input output devices, and if this terminal is equals to logic 0, in that case 8085 will perform memory operations. Now when we talk about second terminal, that is read bar, so that is a read terminal which is active low terminal. What it means, if it is logic 0, in that case microprocessor can perform read operation. That read operation may be there with memory or input output, and that will get justified by this terminal. And third essential terminal of microprocessor 8085, that is write terminal, that is also active low, that's why it is write bar. Whenever it is logic 0, at the time microprocessor can perform write operation. So that write operation and read operation that happens over data line, that you should know. And this read and write operation that will happen with memory as well as input output, that will get justified by this terminal. But when we interface this microprocessor with memory as well as IO, at that time you need to have four different signals. So by using these three terminals, we can generate memory read, memory write, input output read and input output write. Let us try to understand that first. So for that, you should know whenever IO memory bar that is active low means memory operation will happen, and when read bar is 0, write bar is 1 means there is a read operation. So altogether you can say memory read operation that is happening. And when IO memory bar is active low, in that case memory operation will happen. In that if read is 1, write is 0, in that case memory write operation will happen. And if IO memory bar that is logic 1 with read bar 0, write bar 1, in that case IO read operation will happen. And when IO memory bar that is 1, that is indicating input output operation, control signals, those are active low signals, active low signals. Let us try to understand that how we can make NAND gate that is equivalent to signal generation. So you see here IO memory, since it is 0 control signal, and you see read bar, third control signal that we are giving it over here. So here I can say after inversion this will be again IO signal, and you see this is write bar that is directly connected over here, and write bar inversion is write over here. So IO into write and bar of it, that will be IO write bar, that is my fourth control signal. So in short I can say that four control signals, now I can use it for controlling of memory and IO, and here microprocessor does not have these four control signals separately. So by using this circuit connection or by using decoder even, we can be able to generate these four control signals. And here by replacing this inverted input NAND gate with OR gate, we can even generate same signal. So I think now it is clear to you how we generate control signals by using circuit, right? So this is what you need to keep in your mind when you make circuit of generation of four control signals in interfacing of memory as well as in interfacing of IO. This circuit that you'll have to use every time, right? That's why you should remember this even by using. Welcome to Engineering Funda family. This video is a part of microprocessor 8085 video lecture series, and in this video I'll be going to explain you address data demultiplexing in 8085 microprocessor. 8085 in that. So let us try to understand first lines of microprocessor that is there as per 16 lines are there with address and data in 0 to 87. At that time this lines 80 to 87 that will be representing address, and whenever there is logic 0, at that time you can say that this 87 to 80 that will work as data line. So ALE can separate 80 to 87 in terms of address as well as data. Let us try to understand that graphically so that will be more clear. So you see here we are having A8 to A15 address lines, which is there based on multiplexed line will be using address from this 80 to 80. Is what we will be connecting with enable terminal. At that time these lines will be having, and you can say this is our lower address connection is there with all the lines, but I'm going to show you only one line connection. You see how connection is there inside. So here we have D flip-flop. Now with this D flip-flop, you see this 87 line is connected over here, and this D data at output. Now here Q bar connection is there. So Q bar means what? Q bar means inverted data of this D which will be over here. So if 0 is over here, then here there will be 1. If 1 is over here, in that case there will be 0 over here. After that you see here bubble is there. Bubble will invert this Q bar data, and after that there is buffer. So here you see what will happen if 0 is coming here, here there will be 1 and here there will be 0. So this 0 is address. Why it is address? The reason is ALE that is enabled over here. If this ALE that is having logic 0, what it means, this flip-flop will get disabled. And as if this flip-flop is get disabled, here nothing that will come at output over here, right? So this will get don't care. So that is what similar connection which will be there with all other lines, but I have shown with only one connection over here. Now as if this ALE that is logic 0, in that case you'll be having this 80 to 87 that is working as data line, that is D0 to D7. So I'll explain you how exactly all those things are happening in timing diagram. But my dear students, you should know that when we operate with microprocessor 8085, in that with every machine cycle, that machine cycle can be opcode fetch, that machine cycle can be memory read, memory write, input output read, input output write. So with all these machine cycle, at initial fetch will take address at output over here, right? After that this ALE will go down, memory or lines should get fetched initially. Why? The reason is our job is to identify what is the location at which we are able to operate with data. Welcome to Engineering Funda family. This video is a part of 8085 microprocessor video lecture series, and in this video I'll be going to explain you memory mapped IO and IO mapped IO. And by comparison I'll be going to explain you how both of these operations are different. Right? Here usually we are talking about IO means input output devices. Memory mapped IO means what? IO are treated as memory. And IO mapped IO means what? IO are treated as IO means input output devices are treated as input output. The reason is there are some input output devices which are having memory, and with respect to that memory those are functioning. That's why IO mapped IO and memory mapped IO operations are different. How those are different with exact clarity, let us try to understand that step by step. So my dear students, here memory mapped IO and IO mapped IO is listed by points. So let us have first point. See, IO devices are treated as memory in memory mapped IO, and in IO mapped IO, IO devices are treated as IO only. When we talk about memory mapped IO, then as it is memory mapped IO, all the lines which are there with 8085, there are 16 addressing lines, right? So all 16 addressing lines, those are used in memory mapped IO. But when we talk about IO mapped IO, then only 8 bits of addressing lines A0 to A7 that is being used for IO operation, right? So IO mapped IO that is having only 8 addressing lines, and memory mapped IO is having all 16 lines which are there with 8085 microprocessor. And based on the 16 lines, you can say how many possible addresses are there. So with memory mapped IO, 2 to the power 16 means 64k addresses are there with memory mapped IO. And with IO mapped IO, only 8 bits of addressing lines are there. So 2 to the power 8 means 256 number of addresses which are there with IO mapped IO. So as per the addresses, you can say how many devices can be interfaced in terms of memory mapped IO. There can be 2 to the power 16 number of devices means 64k, and exact value in decimal that will be 65536, that is 2 to the power 16. And as there are total 8 addressing lines, number of devices that we can interface over here, those are 256. Now my dear students, let us try to understand how many complexities are there in terms of interfacing and how many hardware requirements are there, right? So in memory mapped IO, as there are total 16 address lines, there are many devices which we are connecting over here. So when you want to enable all those chips which we are interfacing it with this processor, at that time you need many decoder. So hardware will be very complex. You need to have many decoder to identify which devices are operating right now. But when we talk about IO mapped IO, there are only 8 bits of addressing lines. So at max we can interface 256 number of devices. So here decoder hardware requirement will be very less compared to this. You see here how many devices are there? 65536, and relatively you can say that is very low, right, over here with IO mapped IO. So hardware requirement in terms of decoder and connection of circuit, that will be lower with IO mapped IO. But there are some advantages even. See here with memory mapped IO, we are having total 16 lines with 8085. So you can say all the lines that we have already connected over here, right? So with individual device, it is possible that you may have very less memory, right? But when we talk about IO mapped IO, here we are having total 256 at max devices. So with single device, you can have more memory available, right? See, if you interface many devices, then it is very obvious case that with single device, available memory will be less, right? So in that context, it is written over here. With memory mapped IO, if you interface 1 or 2 devices, then you can say you are having larger space of memory available. But if you interface 10 devices, then with single device, obviously your memory availability, that will be lower, right? Now, let us try to understand how many control signals are there with memory mapped IO. So as memory mapped IO is treated as memory, control signals will be memory read and memory write. But IO mapped IO are treated as input output. So you'll be observing controlling signals are input output read bar and input output write bar. And this type of questions that I have seen in interview also, many interviewers are asking when it comes to embedded company. Now, my dear students, when we talk about data transfer, then in memory mapped IO, as it is treated as memory, all the resistors are available, right? So data transfer can happen in between all the resistor and IO. But when it comes to IO mapped IO, you treat that as input output device only. So when it is considered as input output device, only accumulator is available for data exchange with input output devices. Now, here ALU operation, that is getting done with all the resistors, right? Why? The reason is it is considered as memory. But when it comes to IO mapped IO, ALU operation is not available. There is only instructions, those are in and out instructions that will get executed with IO mapped IO, right? Why? The reason is with input output, we are just dealing with to provide input and output operation. But with memory, we do many things, right? So ALU operation, logical operation, arithmetic operation, all those things that we do it with all the resistors with memory mapped IO. And if you want to see some examples of instructions with 8085, then you see with memory mapped IO, we can use LDA instruction, STA instruction, move a memory instruction, right? That is how memory mapping can be done. But when it comes to IO mapped IO, only in and out instructions are available over here. And these instructions that we do it for data in and data out with microprocessor 8085. So here, these are the basics that you must know. See, there are some differences when it comes to some higher cadre of microcontroller, but major fundamentals will remain same. So my dear students, in case of memory mapped IO, you should know that those input output devices are considered as memory. So control signals will be also memory read, memory write, as well as all the address lines are available. And due to all the address lines are available, you can interface many devices. And as you interface many devices, you may need to have larger hardware requirement, right? But when you interface many devices, there will be less memory availability for programming of different devices. And with IO mapped IO, it is considered as IO device only, in that only 8 address lines possible with interfacing. So 256 IO devices can be interfaced with 8085. So hardware requirement will be relatively low compared to memory mapped IO. But there are some advantages which is there with memory mapped IO. The reason is nowadays I have seen many input output devices are having memory operations, right? That's why most of the cases you will be observing that those devices are interfaced in terms of memory mapped IO. I hope you have understood this. Thank you so much for watching this video. Welcome to Engineering Funda family. This video is a part of Microprocessor 8085 video lecture series, and in this video I'll be going to explain you operation types with microprocessor. So there are various operations which are happening outside the microprocessor, inside the microprocessor, as well as by the microprocessor, right? So here I have generally classified operations of microprocessor in 3 categories, and in this video I'll be discussing all those operations in very great details so that you can understand how many things that microprocessor Welcome to Engineering Funda family. This video is a part of we do it for data in and data out with microprocessor 8085. So here, these are the basics that you must know.